Did you know that someone in this country uses a ceasefire to successfully put out a fire every 20 minutes? And that's possible because these extinguishers are built to be fast, powerful and totally reliable. Let's go live now to the ceasefire production facility, where Chief Engineer Ranganathan will demonstrate to us how ceasefire's ABC extinguisher has been designed for rapid activation and major portability, maximum power, usability on multiple classes of fire and utmost reliability.
At this central offloading dock, the various components of ceasefire that we do not manufacture ourselves are received and checked. For the body of the extinguisher, for instance, we use only cold rolled closed annealed or CRCA steel sheets, which are substantially stronger and less brittle than other grades of steel. These are sourced exclusively from a select list of reputed manufacturers who are in a position to offer us quality certification. We also conduct independent tests on these sheets for consistency and strength. Contrast this with the industry practice of buying steel from grey market manufacturers who are in no position to certify the quality of their merchandise. The resulting extinguisher bodies are often brittle with fault lines that may crack and leak. Moving on to ceasefire's extinguishing, the powder that puts the fire out. The active firefighting ingredient in ABC powders is a chemical called monoammonium phosphate, or MAP for short. ABC powders are available in various strengths, with MAP levels going from 10% up to 90%. The higher the MAP level, the greater the firefighting power. The Indian fire trade typically uses between 10% and 50% MAP in their extinguishers. Even those who claim a MAP content of 50% are often actually using adulterated powder or powder recycled from defunct extinguishers. Ceasefire extinguishers contain 90% MAP, making ceasefire far more powerful in putting out fires. Ceasefire sources its ABC powder from the most reputed European suppliers, whose products are tested in laboratories across the world. Ceasefire's technical team also retests the powder independently. The industry norm, on the other hand, is to buy powder at the cheapest price from small, unorganized local vendors. Very rarely do extinguisher manufacturers carry out independent tests on the powders they have sourced. Let's move on to the sourcing of the nitrogen propellant, the gas that drives the extinguishant out with a certain force. The critical factor here is purity. Low-grade nitrogen could introduce moisture into the extinguishant powder, causing it to cake and clog. All Indian manufacturers use commercial-grade nitrogen. Ceasefire uses high-grade nitrogen of a purity that prevents moisture entering the extinguishant. Take Ceasefire's pressure gauge, imported from one of the world's most reputed suppliers. The world's smallest pressure gauge, just 23 millimeters in diameter. It is also remarkably easy to read. It is also the only pressure gauge in the world which can be checked even in the pressurized state with the help of a maintenance magnet. Now let's move on to the actual manufacturing and assembly process, beginning with the container. The container's strength will obviously be affected by the amount of welding on the surface. More welded seams, more chance of leaking. Industry practice in the past was to weld the container all the way down its vertical length and at its top and base. In the mid-90s, Ceasefire pioneered the deep drawn process, where large steel sheets were formed into shape using hydraulic presses requiring no vertical welding at all. So, in this 5 kg container, for instance, the potential leakage area is reduced by up to 57%. For the remaining small horizontal seams at the top and base of the container, we use a mixed CO2 welding process, 100% automated, with motorized fixtures holding the container in place as an electronically guided torch performs a precise welding job. Now contrast this with the industry norm of manual welding, obviously more prone to crack and leak. Next, we have an extensive chemical pre-treatment, what we call the 8-tank process. This is necessary to clean the container because deep drawing involves a lot of oil and grease. Besides, the steel sheets are exposed to air, dust and moisture which could cause rusting.